Today's subject is pharmaceutics 2 and the chapter number 4 is solid dosage form and subtopic is mixing of powders. Then in this lecture we have to see the mixing of powder, that is methods of mixing of powders. In last lecture we have to see the two methods, that is first is spatulation and second is the trituration. And in this lecture we have to see the third method, that is called as geometric dilution. It is one of the method of mixing of powders. And what do you mean by geometric dilution? The geometric dilution is a pharmaceutical process in which the small amount of potent drugs or powders are mixed with appropriate amount of diluents. To ensure the equal distribution of powder by properly mixing the powder, that is small amount of potent drug, with the appropriate amount of the diluent. It is called as geometric dilution. Geometric dilution shows the equal distribution of powder mixture. Then what is this geometric dilution? The method is used when the potent substances are to be mixed with a large amount of diluent. Then what is the use of geometric dilution and when it is used? It is used when the potent substances are to be mixed with the large amount of diluent. And what do you mean by diluent? The diluents are fillers that increase the weight of the powder or dosage form and to ensure the uniformity of the doses. It is called as the diluent, or the fillers are used to increase the weight of the dosage form. Then what is the procedure of geometric dilution? The first step is the potent drug is placed upon the approximately equal volume of the dilute in the mortar, and the substances are slightly mixed by the trituration. This is the simple method. Means this is the first step. We have to take, for example, 100 mg of the potent drug and plus equal volume, that is 100 mg of the diluent, that is lactose it contained, is placed in the mortar and the substances are slightly mixed by trituration. Means first step is the potent drug is placed upon the approximately equal volume of the diluent in the mortar and the substances are slightly mixed by trituration. Then what is the second step? Then a second portion of diluent is equal in volume to the powder mixture in the mortar is added and trituration is repeated. That is the second step. In second step you have to take the 200 mg of the mixture, and where this occurs? It occurs in first step, that is 100 mg of the potent drug plus 100 mg of the means equal amount of lactose or binder or diluent equals to 200 mg of the mixture. Then take this 200 mg of the mixture in the second step or second portion, and you have to add equal portion of diluent, that is lactose, is equal to 400 mg of the mixture. This is the second step. The second portion of the diluent equal in volume to the powder mixture into the mortar is added and the trituration is repeated for the mixing of powders. And the next process is continued, adding the diluent equal in volume to the mixture in the mortar at each step until all the diluent is incorporated. Means the process is continued until the remaining portion of diluent is added in the mixture. Then we have to see the geometric dilution with the form of one example. The example is, if 100 mg of the potent drug is required to be mixed with 900 mg of lactose. 900 mg of lactose means it is the diluent, it is the inert material. Then according to geometric dilution method, the following procedure should be followed. Then we have to see the procedure of geometric dilution. According to step 1, we have to take this 100 mg of the potent drug. Problem contains the 100 mg of potent drug. Then take entire this complete 100 mg of the potent drug in the first step, plus we have to add equal volume of diluent, that is 100 mg of the lactose. Equal volume means because we have to take 100 mg of the potent drug, then you have to add the equal volume of diluent, that is 100 mg of lactose from 900 mg of lactose equals to, it gives total 200 mg of mixture. Mixture contains the 100 mg of the potent drug plus 100 mg of the diluent, that is lactose, equals to 200 mg of mixture. In second step, we have to take this 200 mg of the mixture. That is, this take 200 mg of the mixture plus we have to take equal volume of the diluent, that is 200 mg of the lactose. Equal contains the 400 mg of the mixture. Then we have to continue the process. Then you have to take this 400 mg of the mixture plus 400 mg of the lactose, that is equal volume of diluent. It gives 800 mg of the mixture. Then we have to take this 800 mg of the mixture plus we have to add the remaining portion of lactose. The lactose, it gives the quantity in the example is total 900 mg of the lactose. Then remaining portion of lactose means 400 plus 200 to 600 plus 700. This 700 is minus by 900, means 900 mg of lactose minus 700 mg of lactose. The remaining portion of lactose is 200 mg of lactose. Is add in the remaining portion of the lactose, that is remaining. Remaining portion means that is 200 mg of lactose. Is remaining, is add in the 800 mg of the mixture. Is give equals to 1000 mg of the mixture. The summation is 1000 mg because in this example we have to give 100 mg of potent drug plus 900 mg of the lactose. 900 mg plus 100 mg equals to 1000 mg, and the total summation is 1000 mg of mixture is properly mixed with the help of geometric dilution method. This geometric dilution method ensures the equal proportion of mix the proportion of small amount of potent drug, and second is the appropriate amount of lactose to ensure the proper distribution of the powder. Then next method is sifting. The sifting means the powders are mixed by passing through with the help of apparatus sifter. This process results in light fluffy product because sifter contains the coarse to very fine powders. Then very fine powders is produced or result in light fluffy product and is generally not acceptable for incorporation of potent drug, because potent drug means which are present in very small amount. Then we have to not use the light fluffy product and generally not acceptable for incorporation of potent drugs into a diluent base. This is the sifting process, and this process the sifter is used to mix the powders. And last method is called as the tumbling. Tumbling process is used in the industry, and with the help of blenders you have to mix the large amount of powder in the industry. Means it is the large scale process for mixing of powders in industry. The tumbling is the process of mixing of powders in a large container rotated by an electric motor. These blenders, the blenders are attached for mixing of powders and which is rotated by the electric motors, are widely employed in industry as a large volume powder mixer. The tumbling process are used for large scale mixing of the powders in the industry, and in this process we have to use the large containers which contains the blenders which are rotated by an electric motor and which is used in industry as a large volume powder mixers. Then we have, in this lecture we have to see the methods of mixing of powder, that is third is geometric dilution, then fourth is sifting, and fifth is the tumbling process.